Let's take a look at one more synthetic division question. So we have 3x cubed minus x minus 3 divided by x minus 1. So let's take a look. Does our exponents go down? X cubed, to the power of 1. So we need to put a placeholder there of a 0x squared. So when I'm writing out these coefficients, it's going to be 3, and then I'll put my 0, and then I'll put my negative 1, and negative 3. Now I've got my minus 1, and then I'm going to do a subtraction and a multiplication. Okay, it's all set up. So then I'm going to go drag down this 3, and then negative 1 times 3 is negative 3, and 0 minus negative 3 is positive 3, and then negative 1 times 3 is negative 3, negative 1 minus negative 3 is positive 2, and then negative 1 times positive 2 is negative 2, and negative 3 minus negative 2 is negative 1. So then we go in this cubed, our highest degree is now going to be squared, so it'll be 3x squared plus 3x plus 2 with a remainder of negative 1. So we'll write that using the remainder theorem, so negative 1 over our divisor x minus 1. So there's more that we can do with the remainder theorem than just doing the division. The remainder theorem says that a polynomial is divided by a binomial of the form x minus a, then the remainder is p of a, which kind of is a little bit wordy, maybe doesn't make a lot of sense. So let's look at an example. So we have this polynomial, and we want to divide it by x minus 3, and we want to know what the remainder is. So I'm going to take this 3. Now note that this is a negative already in this form. So it's just going to take the 3, so p of 3 is equal to, and then substitute in 3 for all of our x values. So 4 minus 3 to the power of 4 minus 7. So using our calculator, we're going to actually get quite a large number, negative 298. So this is our remainder. But let's prove that that's our remainder. So my first thing I'm going to do is actually reorder this in descending order. So negative 4x to the power of 4. I don't have a cubed, so I'll be 0x cubed. Don't have a squared either, so 0x squared. And then plus 11x and minus 7. So I'm going to use those coefficients then. So negative 4, 0, 0, 11, and negative 7. And let's set this up. So that negative 3, we got a minus and a times. And now we can actually go and do this. So negative 4 gets brought down. Negative 3 times negative 4 is positive 12. 0 minus positive 12 is negative 12. Negative 3 times negative 12 is 36. 0 minus 36 is negative 36. And then negative 3 times negative 36 is 108. And 11 minus 108 is negative 97. Negative 3 times negative 97 is 291. And then negative 7 minus 291 is negative 298. And the only number we actually care about in this question, because it asks for the remainder, is negative 298. So therefore, verified. So let's use the remainder theorem again to find the remainder. Now there's a second part to this question, and we haven't looked at something like this before, which is use the factor theorem to determine if the divisor is a factor of the polynomial. So we haven't talked about that. That's more of a 3.3 thing, but it will occur in one of these questions. So we have x to the power of 4 minus 2x squared plus 3x minus 4, all divided by x plus 2. And yes, to find the remainder, you can go and do synthetic division or long division, but it's so much longer. The first thing that we have to look at is our divisor. It is not in the form x minus a. So it's actually x minus negative 2. So therefore, I'm going to substitute in p of negative 2 into my original polynomial. So it's going to be negative 2 to the power of 4 minus 2 to the power of negative 2 squared plus 3 times negative 2 minus 4. And you're going to use a calculator, and you'll find out that that's equal to negative 2. And that means our remainder is equal to negative 2. Okay, we answered the first part of the question. And we could put that into the form of negative 2 over x plus 2. But then the second thing, is this a factor? Well, no. is x plus 2 a factor? No. And the reason I know that is because we have a remainder. So if there's no remainder when we do this division, that means that the divisor is actually a factor of the polynomial. So let's take a look at the second question and see if it happens there. So we have 3x cubed plus 8x squared minus 1, all divided by 3x minus 1. Now this divisor also has the same problem. This again is not in the form x minus a. So let's make it into that form though. We can factor out a 3, and it'll become x minus 1/3. Okay, there we go. There's our x minus a. So this 1/3 is what we're going to actually factor, or substitute, sorry, into our original polynomial. So this is going to become 3 times 1/3 cubed plus 8 times 1/3 squared minus 1. You put that into a calculator, and you're going to find that p 1/3 of 1/3 equals 0. So a remainder is 0, so we can put 0 over 3x minus 1. But more importantly, it actually satisfies the factor theorem. The factor theorem says that if the remainder is 0, then the divisor is a factor of the polynomial. So therefore, 3x minus 1 is a factor. Okay, our final question for the section. Use the remainder theorem to find the value of k in the polynomial. So this is our original polynomial. It's being divided by x minus 2. And we're told that when we do this division, we get a remainder of negative 3. So we need to use the remainder theorem then. So the remainder theorem says if I was to actually substitute in 2 for all of these x's, I would get a remainder of negative 3. So if I actually go and do that, so we know it's going to be equal to negative 3, and I substitute in 2 for all my x values. So this becomes 2 cubed minus 6 times 2 squared plus 2 times 2 plus k. And using my calculator, I'm going to find out that this all equals 4 plus k. Subtract 4 off each side, and we find out that k is actually equal to negative 7. So I really like this question. It seems really confusing at first when you look at it, but it simplifies really quickly.